Hi everyone, my name is David, and in this video I will show you the diagnostic process for the selective catalytic reduction system, or SCR system, in modern diesel engines. We will take a closer look at the SCR system, dig into the diagnostics, and discuss the repair. Let's get started. The SCR is designed to reduce nitrogen-oxygen emissions from the engine. It works by adding a special urea solution called AdBlue into the exhaust system. Using a number of sensors and actuators, the engine control system regulates the level of nitrogen oxides. If an irregularity is detected, you'll see an alarm message on the instrument cluster. Usually, that message will also say how much distance you'll still be able to drive and how many times you'll be able to start the car before the engine gets blocked. To perform a diagnostic test of a modern exhaust after-treatment system, you are going to need the following: a mobile computer, gloves and safety goggles. Make sure you wear these before doing any work. A diagnostic device of your choice, a refractometer, test paper, appropriate wrenches, a pressure gauge with adapters, a measuring vessel, tools for operating the SCR system, a battery charger, and vehicle covers. The first step is to prepare the car with covers and ensure a stable power source for the vehicle. We can do this by connecting a battery charger and attaching the protective covers to the fenders for the duration of the diagnosis. To get started with the diagnosis, use your diagnostic device to read the error code memory of all vehicle systems. As you can see, the engine control system has registered an error. It indicates low efficiency of the exhaust after-treatment system, which is directly related to the information displayed on the instrument cluster. Let's see what we can do to solve the problem. Our car has a catalytic converter and a particulate filter. Between them is a reduction agent injector. In this case, the injector is in the same hosing as the particulate filter, as you can see here. The injector is supposed to make sure the SCR catalytic converter works perfectly. The cause of low efficiency in the SCR may be because the injector doesn't correctly dose the amount of reducing agent into the catalytic converter. To find out why, we have to disassemble the injector and perform a proper test. Before we do, let's make sure the car has been fueled with the correct reducing agent. As you can see, the reducing fluid filler cap is located next to the fuel filler cap. In this step, we take a sample of the catalytic fluid from the reservoir. After we've taken a sample, we can test it. We need to check to see if the reducing fluid is not contaminated by substances such as diesel, engine oil, or petrol. If the reducing fluid is pure and uncontaminated, the test paper should remain the same color. Next, we'll measure the concentration of the reducing agent using a refractometer. The concentration of reducing fluid is measured in the same way as a coolant or electrolyte. By placing a few drops of reducing fluid on the refractometer glass, we can measure the concentration value of the fluid. Depending on the manufacturer of the instrument, we are bound by the urea, DEF, or AdBlue scale. This means that the value must be greater than 32.5. According to the refractometer, the reducing agent meets quality standards, so we can put the blue cap back on and move on to the next step: testing the dosing module. In order to perform this test, we need to remove the dosing module. We'll also check the pressure generated by the delivery pump. That will allow us to determine the condition of the entire reducing fluid dosing system. To check the dosing module, measure the amount of reducing agent dispensed over time. To do this, we will use a measuring vessel. To perform the diagnostic test, select the appropriate option in the menu. In our case, this option is AdBlue Injected Quantity Test. Alright, so we've started the test. Now take a close look at the pressure gauge readings and monitor the filling process of the measuring vessel. After the test, we need to check the amount of liquid of the reducing agent in the measuring vessel and compare it with the reference value displayed on the computer. In our case, the correct amount of agent is 164 to 166 millilitres. As you can see on the scale, the amount of fluid deviates from the required value, so we need to consider where the problem occurs. During the test, we've seen that the pressure generated was correct, so we can logically conclude that there has to be an issue with the dosing module. So our next step is to replace the dosing module. Remember, follow the manufacturer's procedures closely and verify the part number of the component you're replacing. You can find the part number on the injector module. You also have to make sure that there haven't been any post-manufacturing changes. You can find out by logging in and checking the documentation around the dedicated part number. To make sure that we've correctly diagnosed and solved the problem, we'll have to run a few other tests. This time, we don't need to check the pressure since we've already seen it was working properly in our last test. When replacing a delivery pump or tank, we first need to perform a leak test. This is done using the bleed system AdBlue circuit leak test function. As you can see, the results are all good. While performing the leak test, the SCR system pump generates maximum pressure and then shuts off. Our job is to make sure that the set pressure value in the system doesn't drop, because that would indicate a leak between the tank and the dosing valve. Now that we've concluded the leak test, we can move on to the AdBlue injected quantity test. This is where we can confirm that replacing the dosing valve has resolved the issue. This injected quantity test is similar to the one we did earlier, except that this time we no longer need to measure the fluid dosing pressure. This time, we can see that the amount of reducing fluid is dispensed correctly and well within the acceptable range. Now, we have to fit the dosing module to the exhaust system and reset the SCR system adaptation using a diagnostic tester. That way, the engine controller will adapt when we do a test drive under road conditions. We then reset the SCR system to its basic settings and clear the errors in every single one of the vehicle's systems. Then, the time has come to take the car for a little test drive. Remember that you'll have to have another person driving, so you can focus on operating the diagnostic tester. Doing both things by yourself is dangerous and illegal. Also, make sure that you're driving with a medium engine load at a constant speed of about 80 to 100 kilometers per hour. To make sure the system is working properly, take a close look at the SCR pressure value, the dosing module control, the nitrogen oxide, and exhaust temperature sensors. When the SCR system starts its dosing module, the concentration of nitrogen oxide after the catalytic converter should be lower than the concentration before the catalytic converter. To test this, there has to be sufficient exhaust gas temperature and engine load. That's why we need to do a test drive to see if there are any leaks due to incorrectly connected cables or badly replaced hose clamps, for example. Remember to reread the memory of the vehicle system's error codes after the test drive and inspect the SCR system for any leaks. You can find the error clearing option in the same menu as the test function. Alright, that's it for today. This is everything you need to know about the diagnostics of modern exhaust after-treatment systems and how to repair them. Thanks for watching.